Hi, today I'm going to show you how to design the branch-high couplers using FILPAL EDS. Branch-high couplers is a very common device you can find in most microwave systems, as it can be used to couple or decouple the signals in different ports. And branch-high couplers is a 4-port device. So here you can go to the LARM toolbox and drag the 4 ports, and you double left click to rotate the ports. And all these ports are referenced to 50 ohms systems, which is very common in microwave design. And we go to the ideal line toolbox here and insert the transition lines. So we right click and input all the values for the characteristic impedance, the frequency of operation. You can click this drop down button to select the prefix unit, and this is 90 degrees for the electrical length. And you can use the shortcut key to actually copy and paste Ctrl C and Ctrl V. So, and this one you can double left click to rotate it, and this the impedance we made it 50 ohms, and similarly on this side. So you can see a branch-high couplers is actually a symmetry design. So we can make the connections between the ports and the lines. Okay, so here you form a ideal branch-high couplers. So you click on the plot button, and you will see the all the S parameters responses. So since it's a 4 ports, so we have all the possible S parameter responses displayed on the graph here. Of course, we haven't changed our frequency range. We can go to this setting page where we can change our simulation setup, as well as the transmission lines properties with different line types. So here we set the frequency range from 100 megahertz to 2 gigahertz, for example, because the operating frequency is centered at 1 gigahertz. So you go back here and report the responses. So you can see we have a pretty nice branch-high couplers designed. So if you look at, first of all, we look at all the input reflections coefficients for each port, S11, S22, S23, S44. You may see they all are we're having a very high return loss at the center frequencies, meaning that there is no reflections. Whatever input into each port, there is no reflected signals. So it's perfectly matched at the center frequencies of 1 gigahertz. So let's see how the power is being coupled to port 2, port 3, and port 4. So here we look at the S21 state, and S31, and S41. So here you can see at this center here, you have a -3 dB power at port 2, and the green line here is for S21, and the brown one is S31. So you have the same power coupled to port 2 and port 3, split into half. That's why you have a -3 dB splitting between the port 2 and port 3. However, at port 4 is a decoupled port where there is no signals appears at the port 4. So you can have a very good isolations between port 1 and port 4. Okay. So this ends the demonstrations of the branch line couple design using the ideal transmission lines. Of course, if you want to physically realize these branch line couples, you can always replace all these ideal transmission lines with the line types that you desire. As an example, microstrip. So you can replace this TL line with the microstrip. And we have an inbuilt calculators or synthesizer to help you to actually work out the corresponding physical dimensions according to the characteristic impedance that you inserted. For example, let's say this is 35.3 ohms and this is 90 degrees and your frequency is 1 gigahertz. In order to construct this TL1, so we automatically calculate the width and the length for you. Okay, so this is 90 degrees. So here you can find the physical dimensions for the width as well as for the length. Okay, so you can do so for the rest of the transmission lines, and then you can export the Gerber file for fabrications. Thank you.